Hi, my name is Nur Aifah Natasha binti Muhammad Azman, and today I'm going to introduce our group members, starting from me, which is Nur Aifah Natasha binti Muhammad Azman. Next is Nur Aisyah binti Rocky, Nur Aina Inshira binti Muhammad Sani, and the last one is Nur Syafiqah binti Ciani. The Engineering Geology field trip on June 28 to 29, 2025 included site visits to Air Hitam, Teluk Iskandar, Kampung Tanjung Risang, and Pantai Air Papan. During this trip, we explored different types of rocks and geological features while collecting data on slope orientation, deep angle, and deep direction. We applied geomechanical methods such as rock mass rating, Smith-Hammer, and point load testing, as well as stereonet kinematic analysis. These hands-on activities help us understand rock mass behavior and supported practical learning in slope stability assessment for safe engineering design. Our objectives are to classify and characterize rock types through geological mapping and field observation, and to evaluate weathering rates using IRM standards. We assess rock mass quality using in-situ tests like the Smith-Hammer and point load, and analyze geological structures with a clinometer app. Finally, we determine slope stability through kinematic analysis and apply the RMR system to evaluate engineering suitability of the slopes. For this study, we focused on 4 slopes, 2 man-made Air Hitam in Kampung Tanjung Resang and 2 natural Teluk Iskandar in Pantai Air Papan. We collected data using rock sampling for load tests, skyline mapping for joint recording, and select durability tests for weathering resistance. We used a clinometer app for quick dip and direction measurements, and a Schmidt-Hammer to test surface hardness and estimates UCS. For stability, we applied RMR by marking 2 by 2 meter grids, counting joints, and observing rock conditions, then calculated as SMR by adjusting RMR with slope factors to classify slope stability.
Next, my name is Nur Aina Inshira binti Muhammad Sani, DF240092, will be presenting Site 1 in Air Hitam, Johor. Alright, next, the Site 1 is located at Air Hitam, Johor. The rock type is fine-grained sedimentary rocks that originated from volcanic ash mixed with silt or clay deposited in a marine or volcanic basin. The weathering is slightly weathered rock with some minor sign of decomposition and discoloration. And the geologic structure, it is a joint, which is the fracture in the Earth's crust, often caused by tectonic forces, where rocks have split along a plane of weakness. Alright, next is a rock mass rating and strength. First, we have a ribbon hammer, which is we get 19 MPa. Okay, for the second one is a mapping. The joint total we get is 51, where we classify it in yellow, red, blue, purple, and green. For the third one is a volumetric joint, where we get 25.5. For the fourth one is RQD. The RQD that we get is 30.85. Next is a discontinuity spacing, where we get 0.27 meter. And the last one is RMR. The total rock massing rating that we get is 61, where it is in a class 2, which is good rock, where RMR is 61 to 80. And the excavation is full face. And alright, next is a discontinuity data collection. This is the face slope, which is deep direction is 101 and the angle is 25. The upper slope is deep direction 101 and the angle is 48. And this is the discontinuity sense. Alright, next is a rock mass rating and stretch. For the first one is F1, which is joint oriented correction factor. F1 is equal to 0.9135. For the second one is F2, which is type of failure, where we get 2.90. And the F3 is a deep angle relationship, where it is significantly steeper than the slope, and the condition is unfavorable, and we get F3 equals to -6. Alright, for the fourth one is a F4, which is excavation method adjustment. The slope is naturally formed, where we get F4 equals to 0. Next is a SMR calculation, where we get 45. And number 6 is SMR classification, where we get class number 2. And the SMR value we get 61 to 80, And rock mass description is good, stability is stable, and the failure is somewhat failure, and the probability of failure is 0.2. And the SMR classes that we get is 2B, which is to ditch and or nest, sport or systematic bolting.
So here is our site 2, which is Teluk Iskandar at Mersing. This site is Teluk Iskandar in Mersing, Johor. The rock types found here include shiny crinkled foliated shale and hard, glossy quartz sandstone. The rocks show slight weathering with minor signs of decomposition or discoloration. In terms of geological structure, bedding, faults, joint and folds are present, creating fractures that can weaken the rock structure and increase the potential for slope instability. At site 2, we identified 3 sets of joints. The first set has an average dip direction of 275 degrees with a steep dip angle of 74 degrees. The second set shows a dip direction of 230 degrees with a dip angle of 82 degrees, also very steep. The third set has a dip direction of 41 degrees with a gentle dip angle of 13 degrees. This joint set help us analyze the slope stability and potential failure planes.
Assalamualaikum and good day. For my part, I'll be presenting on Site 3, which is located at Cherun Tanjung Penyambung, Johor. This site was investigated to assess its geological characteristic and slope stability based on field observation and rock mass classification system. This slope is composed of pyroclastic volcanic rocks, specifically turf, which appears grayish-brown in color with fine to medium grain size and has a brittle texture. In terms of weathering, the rock shows light to moderate weathering, with outer layer weakening, especially near cracks. The geological structure included numerous joints and fractures, which could potentially affect slope stability due to water infiltration and accelerated weathering along these discontinuities. To calculate the rock mass rating (RMR), several key steps were followed. First thing first is rebound hammer test. Blind readings were taken and the average rebound value was 13.28. Using the standard conversation factor of 0.6, the UCS was estimated at 8 megapascal. Next, scanline mapping. We conducted over a 1 times 1 meter area. A total of 90 joints was recorded and grouped into 3 joint sets, each identified by color red, yellow, and blue. And next, volumetric joint count (JV). We calculated using the formula shown in the slide, giving a value of 19. The rock quality design (RQD) calculated as RQD equal to 115 minus 3.3 times JV, we got 52.3%. And last and not least is continuity spacing. Average spacing calculated as 0.21 meters. So, to get the RMR value, we refer the RMR classification table. Each parameter will assign a rating. UCS from ribbon test is 1, RQD 13, joint spacing 10, and discontinuity condition, roughness, weathering, and age is 30 total from all subcriteria, and groundwater is 10. By adding up all this rating, we obtain a total RMR of 16, which place the rock mass in the fair category. The discontinuity data was collected using a clinometer for all measurement. The first slope has a dip direction of 149 degree and a dip angle of 44 degree. The upper slope has a dip direction of 54 and a dip angle of 58. A total of 30 discontinuities were recorded, each with specified dip direction and angle. From this data set, the most critical joint was selected and used in the SMR calculation. The slope mass rating (SMR) is calculated using the RMR value and 4 adjustment factor. First, F1 is joint orientation correction factor. The critical joint 19, is nearly parallel to the slope face. So we got F1, we using the formula, we got 0.9986. Second is F2, type of failure. This is identified as planar failure since the joint dips in the same direction as the slope. So we got F2 is 0.90. And next, F3, dip angle relationship. The slope and joint dip angles are only 2 degrees apart, so F3 is 0. And lastly is F4, excavation method adjustment. As no blasting or excavation occurred at the natural slope, so F4 is equal to 0. Putting all values into the formula, SMR is equal to 60. This places Cherun Tanjung Penyambung under SMR class 3, meaning the slope is partially stable with potential for planar and wedge failure. We suggested support measure for class 3 slope includes construction of tow ditches or installation of protective nets. Next, spot or systematic rock bolting in a stable zone. And lastly is spot application of shotcrete, especially over fractured or weathered areas.
Assalamualaikum, my name is Nur Aisyah binti Rocky and I will present for Site 4. For site 4, we go to Pantai Air Papan. We observe mostly sedimentary rock that form from marine deposits like siltstone and claystone. Interestingly, part of the site also show low-grade metamorphism, indicating past tectonic activity. In terms of weathering, the rock in this site is fresh, which is grade 1. This variation means the slope has strong zone with no visible sign of decomposition or discoloration. Structurally, we identified joint, fault, and fault with 3 major joint sets. While we didn't obtain UCS or RMR value, we can say the slope show variable stability, especially in area with highly weathered rock. For discontinuity set, the discontinuity set is deep direction / deep angle. We got the average of 147 degree / 72 degree for the first joint set, 202 degree / 37 degree for the second joint set, and 0 to 1 degree / 45 degree for the third joint set. Next, I will talk about discussion. Across all 4 sites, we saw a wide range of geological conditions. In Site 1 and Site 3, which were man-made slope, gave us measurable data like UCS and RMR. Both show partially stable slope, with recommended support like bolt and short grit. Site 2 and Site 4 were natural slope with more complex geology like faults and metamorphism, but lack some numerical data. One key finding is the structural feature like joint and fault significantly affects slope stability more than just rock type alone. Also, the degree of weathering play a big role, especially at Site 4. Last but not least, we have conclusion. In conclusion, this study gave us valuable hands-on experience in engineering geology. We learned how to classify rocks, measure slope stability, and interpret structural geology in real setting. Most importantly, we now understand how geological feature and weathering can impact slope design and safety. This project not only strengthens our technical skill but also show how crucial geology is in planning safe and sustainable civil engineering projects. That's all from us. Thank you.